Hello everyone, this is Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. Today we are going to discuss about a case study on influence of morphology in image processing, dilation and erosion applications in biomedical image processing. Okay, remember the gray level thresholding. See here the input image. See here we have to set threshold values here. See the input image and gray level thresholding of the particular image, and this shows the example for binary image. So the problem is here because there is no exact boundary here, some pixels are missing. How do we fill missing pixels? How do we fill this missing pixels? Here we need a technique which is called morphology. In morphology we are using erosion and dilation techniques for enhancing the image. So we have to add, or we have to remove, or we have to encounter the missing pixels. We need some kind of morphology operations which is called erosion and dilation techniques. Okay, mathematic morphology, we have pre-processing, enhancing object structure, segmentation and quantitative description we have. Here in pre-processing, noise filtering, shape simplification was done here, and in enhancing object structure we have skeletonization and convex hull. Segmentation we have watershed, and quantitative description we have area and perimeter counting and applications. Here in Z square and Z cube, certain mathematic morphology represent the objects in an image. Here the binary image is 0 as it is equal to white and 1 is black. The element of the set is the coordinates xy of the pixel belong to the object Z square. In grayscale image, the element of the set is the coordinates xy of pixel belong to the object and the gray values and gray levels Z cube. See the basic set theory. See here the two sets of A and B. The union of A and B is shown here, and the intersection of A and B, and the complement of A and the difference between A and B. A, B, two sets are considered. Union of A, B, intersection, complement and subtraction is mentioned here. This is our basic set theory. Here for this basic set theory we have to implement the morphology operators in image processing. Depending upon this basic set theory, we have to implement the dilation and erosion techniques in biomedical image processing. Okay, and here we have to consider the reflection and translation. Here the translation of A by Z and reflection of B, the sets of A and B are shown here. See here the translation and reflection of A and B. See the example. Some logic operations between binary images. Black represents binary ones and white represents binary zeros in this example. See here, first we have to consider the set A, and while performing logical NOT, the output is NOT of A. And in second, third, fourth and fifth row we have to consider both the sets. First operation is AND, and the output is A and B. Second one is R, A, R, B. Third one is XR, A, XR, B. And the final one is NOT of A and B. Okay. Structuring element. Here small set to probe the image, and a study for each SE. Define origin and shape and size must be adapted to geometric properties for the objects. See here the example. Here we have to consider this small set in each and every pixel of an image. Here in structuring element, the first row examples of structuring elements. The second row it represents the structuring elements converted to rectangular arrays. The dots denote the centers of the structuring elements. Here first one it represents the origin, and final one it represents the centers of the SE structuring elements. Here, in parallel for each pixel in binary image, check if SE is satisfied. Output pixel is set to 0 or 1 depending upon the used operation. Here pixels in output as white and pixels if check as SE fits. If SE is not fit, we have to apply either erosion or dilation, any of the morphological processing operators. Here erosion means it is shrink, dilation is grow. Okay, opening and closing object we have to consider. Actually, we have to keep general shape but smooth with respect to the object and the background. Okay, what is erosion? Does the structuring element fit the set? Erosion of a set A by structuring element B all Z in A such that B is in A when origin of B is equal to Z. Shrink the object is called erosion. See the example. Shrink the object, it is called erosion. Okay, what is dilation? Does the structuring element hit the set? The dilation of A by B can be understood as the locus of the points covered by B when the center of B moves inside A. Actually, it is used for grow the object. See the example for dilation. It is used to grow the object. And dilation is used to bridging the gaps. Here, the sample text of poor resolution with the broken characters, and second one is structuring element, and third one is dilation of A by B. The broken segments were joined here. So finally, we will get the perfect enhanced image. Duality of erosion and dilation. Erosion can be computed as a dilation of the background. Same duality for dilation also applied here. Actually, erosion is the removal of structures of certain shape and size given by structuring element. Dilation is filling of holes of certain shape and size given by the structuring element. Actually, what is the use of combining erosion and dilation? Here, we want to remove structures or fill holes without affecting remaining parts. So, the solution is to combine erosion and dilation using the same structuring element, because the origin of the structuring element, it makes the pixel to fully or remove the structures based upon the applications. Okay, erosion, this is an example for eliminating irrelevant details. See here the images of squares of size 1, 3, 5, 7, 9 and 15 pixels on the side. Second one is erosion, and final one is the output of erosion with the same structuring element. Here the structuring element to B, it is equal to 13 cross 13 pixels of gray level 1. And erosion followed by dilation is denoted as opening 0. It eliminates the noises and protrusions in the image, and it breaks nicks and smoothes the contour lines of a particular image. See the example for opening and examples. Opening with a 11 pixel diameter disc and 3 cross 9 and 9 cross 3 structuring element are shown here. 3 cross 9 is first one and 9 cross 3 is second one. Dilation followed by erosion denoted as this dark dot, it is called closing. It smooths the contour, views narrow breaks and long thin gulfs. It eliminates small holes and it fills gaps in the contour. Closing and opening. See the example for closing, which is entirely different from opening. Another closing example. Closing operation with a 22 pixel disc closes small holes in the foreground. See how an input image is turned into output image. And the threshold closing with a disc of size 20 is another example. Note that opening is the dual of closing, and opening the foreground pixels with a particular structuring element is equivalent to closing the background pixels with same element. And applications, we have filtering applications. First image is erode, and second one is dilate, and third one is dilate and erode. Here we use some logical operations for an example. Here another example, a simple binary image with ones represented in white result of using with structuring, same structuring element. See here, a simple binary image with ones represented in white. See here the binary images, the white dot inside one of the region is the starting point of the region filling algorithm, and the result of filling that region, result of filling all the regions. Thank you.